Okay guys, here's a build video. It's going to be different kinds of audio in here. Not going crazy making a super edited video, but should be enough information contained within this video for you to build one of these on your own. It's a little bit long, probably takes almost about the same amount of time to build one. Right here I'm printing it out. I'm using lightweight PLA. There's a lot of threads on lightweight PLA. It's in vase mode. I put two bottom layers and no top layers on all the pieces. I do print a line, a brim, but it's not attached, just to clear out the nozzle before I print. And it's a 0.4 head. This is a volcano nozzle, so temperature is a little lower than, like, say, on an Ender or something like that, because has more time to heat up. But in the RC Groups thread, there is all the information you need on my settings. You're going to have to experiment with lightweight PLA on your own, but the trick to this is printing it in vase mode. All right, hope you enjoy the video and good luck with your build.
So I'm going to be making a new one for the instructional video, but I'm taking apart this old one because I crashed it. I was making a repair. I could just make the repair and then fly this one, it would have been fine. But I'm ripping it open. You can kind of see how I ran everything. You can see where the wires are run, where these trays are glued into. Okay. I made holes here through the firewall to get to the motors. I did that by sticking the X-Acto knife through there and spinning it more or less through here and just spinning it around, drilling a hole will get you that hole there. Same thing with the battery wire. I made those cuts through here and then just ran the battery wire. And then I decided to make an extension instead of soldering new wires onto the board because that's tedious, and if you screw up the board, they're very expensive. Okay, so here I have my wrecked SR71 I took apart. I'm going to use this to get my measurements for cutting out the servo trays. So we have 25 millimeters from the base of the exhaust nozzle, and then roughly 35 millimeter opening. So I'm going to mark that here. 25 millimeters, then another 35. Do the same for the other side. Doesn't have to be exact. Double check that. Good. Use the sharpest knife you can. I'm going to cut this first here just by lightly scoring it. Oops. Don't want to go off like I just did. If you're using a sharp knife, you probably only have to score it about 2 to 3 times to get through. Stuff cuts like butter. And you see, that's why I cut this side first, because when it broke almost right on the line that I marked. You'll have to forgive the noise in the background. I got 3D printer going, the heater's going. It is New Year's Day here, 2021. Goodbye 2020. And I live in New York, so it's heating season. So much quieter when the furnace shuts off, right? Okay. If I make the big time, I'll make a studio with soundproofing. And you can see this was black inside, just like that one. I just painted it silver. I bought the black PLA thinking it would look good, but the black PLA just melts in the sun. I haven't had to go at lightweight PLA ASA yet. Not sure if I will. You need an enclosed fill chamber, all these different things. I don't know if it's worth it just to make one black plane. And when I was flying, I made one that was black. And when I was flying it, I couldn't see it, the orientation. And it was a lot bigger than this one. In fact, I'll show it to you right now. Okay, now I have 2 openings for my servos. I'm just grabbing some servo holders here that I haven't cleaned up yet. These are going to go in here like this to hold the servos. And they go inside. I don't know if you can see that. Inside there. And inside there. This was my first version. You can see it's a lot bigger. It's printed with a 0.6 nozzle. This weighs a lot more than this. It's a carbon rod. I was using that much control surface, which you didn't need. But if you can see the warping, that was because it melted in the sun. So this airframe looks like crap now. And it was white. I painted it black. You can see where I had everything cut out in the battery pack. So it wasn't good. It needed more powerful motors. That's why I built a smaller frame like this. Better flight characteristics. Okay, the next step is going to be the control board. Control board roughly goes right about there. I've always put it maybe a 1/4 inch back, 5 millimeters back from this double firewall here. I'm going to move it back a little more. I noticed I had to move my battery all the way back to get roughly the proper CG, so I'm going to move this back a little more, put a little weight towards the rear, and then maybe I could play around with the battery and flying something a little tail heavy. Now I don't go crazy on this. It's pretty much the opening is going to be to these lines here to here. So I'm going to go about 10 millimeters back now. Let's get a little more going. Get a visual for the camera. I don't know if you can see these marks. Roughly there. Again, cut against the grain first. I'm just freehanding it. If you want, you can save this cutout piece and try and glue it back, but I find just leave the bottom of the plane open. You never really see it. And you want to be careful cutting this. It's easy to go too much. Like that. But I didn't go too much. And once again, you could use this as a hatch if you wanted to tape it back on or something. I don't do that. Maybe on a bigger version I'll do that. There you have it. Now you have to cut a hole through here and here for the battery. And I do that just by pushing the razor knife down. I'm going through 4 layers of lightweight PLA. You want to cut a hole big enough for a JST connector. I don't know if you can see that or not. I also am cutting through glue because that was glued. On this one I cut the hole before I glued it, which is probably what I should have done here. Trying not to use too much force. Okay, I think that hole's big enough for a JST, if you can see it. You can kind of see in there. And then I'm going to put another hole here for the JST connector. Once again, this is the single wall, so you want to go through against the green first and then go across the green. That should, I already broke it, so there's a piece floating in there. There it is, I got it out. So, because the wires go through here, I'm going to reinforce this with a little bit of glue. Because the wires going through here is going to break this apart. As you unplug and plug in the battery, it's going to break. Put like a little bead, 3 or 4 millimeters wide, around the whole opening. And let that soak in a little bit. It should wick in there. A little hardener. Be careful with that accelerator on the paint. It does dissolve the paint. And then if I put my finger on it now, I'm going to smudge it. So I'm going to let this dry a little bit. I'm going to keep my fingers away from it. Now this is ready. I'm going to take these servos off because I got to fish these through. Now this wire can go straight back in the airframe, or if you want to poke a hole, stick it out, you can do that also. Now for gluing this down, I use like a foam tack type of cement. This is not foam tack, but it's made by the same company. It's almost the same product. Seems to hold better than the CA, because the CA is a little too brittle. If it flexes in a crash, it'll pop the controller off. I'm going to get that wire in there. Now this is your flight controller, so you want to mount it as level as possible. So take care to make sure that it's in the airframe level.
Okay, just sped the video up here. Basically, I was just having a hard time getting the board to be level. The wire was kind of pulling on it a little bit, so I just sped the video up, save some time. Don't need you to suffer and watch me line this board up, but you want to be careful and make sure that it's as level as possible.
Oh, that's in there good. Okay. So far so good. So now the next thing, if you printed this in vase mode, so I'm going to run this wire through here. I'm not going to plug it in yet. This control board is still drying. And then I'm going to take my servo holders, my servo tray, whatever you want to call it. I'm going to put this in here also. Notice how it goes up into the wing. This is also 2 layers, the wing. So do this right, should be able to get it in there too. Okay, so I messed up. This wire really needs to be on the other side of this glue joint, because this gear is going to be facing this way, and I don't have enough slack. So I'm going to gingerly cut this open to move the wire. And I did put a lot of glue in there, so probably not going to be so easy. And I just cut the whole airframe. Okay. Well, since that glue joint is so rough, strong, I'm just going to cheat here and run this wire through the cut that I made and then repair it with a little bit of glue. Now, the way you want to position this servo is you should center this with your radio on beforehand, and then get this little Z-bend should be right even with the tail. And it's okay to tilt this a little bit diagonal. I'm actually going to put this in the center of the servo. This is in the center, and this Z-bend is even with the end of the wing. Right there. And that's where I'm going to glue it. Just a drop of glue on the four corners. That's all you need. Do not get glue on the gear. So this is my repair. This is my repair from the cut I made. See, I have my GoPro app working on my phone there. So I can kind of see what I'm doing as I self-video myself. So next we're going to put this servo holder in. And actually I'm going to run the wire first. We learned our lesson from the other one. The wire has to go up and over. Get a closer view of that. Okay. Wire goes up and over, and then glue. You might be able to see better now. This little gap in here is where your wire is going to go.
Okay, this is just me showing the right way to get the wire through. The first time when I did the other one, the other side, the GoPro was on the desk and you couldn't see this good, so you can see a little better now.
Wire goes in the middle hole. I kind of center my servo by eye. Now we can put the servo holder in there.
I'm just positioning the servo tray and try to get glue out of my old bottle of glue. Probably should have bought a new bottle just for making this video, but this one's still got a lot of life in it.
Doesn't need much to hold it in there.
Okay, over here I'm just positioning the servo and gluing it in. Again, be careful not to get glue in the servo gears or in the worm gear.
Roughly the Z-bend here is even with the trailing edge. Same here. You can see the Z-bend is even with the hinge point of the elevator, elevon. And I designed this to go up and over so that the hole in the control horn will be even with the hinge. Okay. Then the control horn is that big for a reason. It has to do with the PID tuning of this board. If this was too small, this would react too fast and the plane would overcorrect itself. And for the hole.
Okay, over here I cut forward a little. I didn't show you doing the first one, but I'm here. I'm taking a little finger drill. The wire of the coming off the servo is about a 0.5 millimeter. I used a 0.66 millimeter finger drill. You can't print that out, obviously. That's too small of a hole. The foaming of the lightweight PLA wouldn't allow that hole to happen. So it's not in there, and you just eyeball it, make sure that the hole is over the hinge point, and leave enough meat on there. You know, you can measure it out if you want and center it in the top part of the control horn there. And then I'm just putting the wire through the control horn, and then we'll do the hinge tape. So I had to go look for my blender there, and I got just a little bit left. You're gonna cut the length of the hinge a little bit longer than the hinge itself, and then I trim it afterwards. And I use a little contact cement on the model itself and not rely just on the glue of the tape. There's other ways of doing it. Right there I was actually putting the glue on the wrong side. So glue goes on the top, because if you notice, the elevon has a tapered edge so that it can hinge without binding. So now I'm putting it on the right side, and then I'll stick the tape on there. And it's a little bit longer, and I just trim it with a knife. The glue really makes sure that it stays on there.
I mean, you can use the blender arm without the glue if you don't want to make a mess like me, but I just find that this is more durable. I've tried a couple different things so far, and this was the best one. Maybe not the prettiest, but I could touch that up with some paint if I wanted to. Alright, that's all in. I suppose I could go ahead and test Make sure they work good.
So over here I decided to test my build, and I did exactly what I said you shouldn't do. I got a little bit of glue on the gear of one of the servos, so that's how it wasn't working. But thank God the glue doesn't really stick to the nylon of that gear too well, and I was able with a razor knife and a magnifying glass to clean the teeth of the gear out and got it to work. You can see me struggling here. I thought it was plugged in the wrong spot, but it wasn't. And I got it to work once I cleared it.
It's not making any beeps because there's no motors. Left, right, up, down. Looks good. And you definitely want about that much up. Let's see if I can get this thing in there. You want about that much up when you're taking off. Okay? Alright. That works. Now for the motors. It's my slot car track. So these were ripped out of that plane. So I'm going to go ahead and can't really reuse these.
Okay, over here I'm just taking the motors off my other damaged frame. Not going to reuse the motor mounts because the glue was in the way. So I printed up some fresh motor mounts, and that's that. There's definitely a right and a left motor. You probably want to mark those before you take them off the Ultrix. But I guess in the end it doesn't matter which way the props spin. If they're spinning both ones, the left one's a counterclockwise or the left one's clockwise, and maybe it doesn't matter. Maybe somebody can correct me in the comments. But I have it so that the tops of the propellers spin towards the center of the fuselage. So over here I'm just drilling some holes through the firewall there where the two sections join, and the other SR71 that I built in the beginning of the build video, I made the holes before I glued it together. You can take your pick. And then in this next part I'll show you how to snake the wires through. It's actually having trouble remembering it myself because I built it
I
so
think I
long
remember
ago.
what I did now. Okay. So you can kind of see it poking through there. Get myself a little wire. This is some MIG welding wire, aluminum. It's come in handy so many times for so many things. So I'm just going to make a little hook to fish this through. Just like that. Easy peasy.
So yeah, here I just do the other side. I explained that motor mount's a nice tight fit if you feel your prints are okay, but don't rely on the friction to hold the motor mount in. You definitely want to thin CA it so it stays in there. And I snake the other wire through.
Now if you wanted to be neat, you could take the piece that you cut out of there, and tape it back on. These wires do stick up a little more than the airframe though. So, but you could just tape that back on. And likewise, if you wanted to tape these on here with a little cutout for the servo horn, you could do that for the control wire. You have to put some kind of slot in there, and then you could easily seal up the bottom of the plane, or even just a piece of tape over it to protect it. I haven't found a need for any of that. When it's flying, you mostly see it like this. If it turns, you don't really notice the bottom too much as it's going by. Okay. That's pretty much it. That's your build video. You're going to put your props on there. Put a piece of Velcro in here for your battery. I can quickly test these motors. Make sure they work.
So over here, went to test the motors, and one motor wasn't spinning. What I didn't do was I didn't clean a little fragment of PLA off the motor mount print. It was that little nipple that gets left over at the end of the print. So I had to take the motor off, trim it with a razor knife, put it back together, and then everything was fine again. So other than that, you don't have to do anything to the motor mounts. They should work fine.
And maybe you learned something from watching me correct my own mistakes. I don't know. It should work now. It works. And that's why I made sure it works before gluing it all together. Make sure these are all the way home when you glue it. Oh, music to my ears. Alright. I have some stickers I'm going to put there. Put the props on, the Velcro, and that's it. This will be ready for a test flight. $44 grams. This is an 800. I don't really fly with that. I think the 450s I use are 14 or 15 grams. And that's it. Thank you for watching.